In this video, I will be going over a two-sample t-test. We've seen this data before. It's located right here at this link. This is the hurricane data, and you might remember that earlier in the course we had mentioned that there are some scientists who tried to suggest that female named hurricanes were actually more deadly than hurricanes that were named with male names. And although we're not going to get into the specifics too much of their argument, they didn't actually use a two-sample t-test. They used some other statistical tests. And if you were to look this up, what you'd find is there are scientists that are going back and forth arguing with each other whether or not their conclusions are accurate and whether or not the tests that they used were appropriate. So we're going to take a very simple approach with this data set. But just know, if you were to go look that up, you would find some very deep statistical conversations about the validity of the models that they use. So with that being said, what we're going to do is to use this data set, and we're going to specifically test this claim. We want to know whether or not there's evidence to support that the mean number of deaths for female named hurricanes is greater than the mean number of deaths for male named hurricanes, and we want to test this with an alpha level, significance level of 0.05. Now, I'm actually going to go over this problem using StatCrunch in two ways. One of them is to use the summary statistics, so we'll first calculate some summary statistics, and then I'll show you, since we have a raw data set, how StatCrunch can be used just using the with data menu instead of the with summary menu. So the first thing we need to do is since we're talking about two parameters, in this case the parameters that we're talking about are means, we want to make sure that we specifically state what our parameters are that we're going to be testing for. So what I'm going to write in here is I'm going to let x1 equal the mean number of deaths for female named hurricanes and x2 equal the mean number of deaths by male named hurricanes. These are the two parameters that I'm using. Right? I'm looking at the mean number of deaths for both of these groups, and they're independent of one another. The claim that's being made here is that x1 is greater than x2, and that should make sense. x1 is the mean number of hurricane deaths by female named hurricanes, or the mean number of deaths by female named hurricanes, and x2 is by the male named hurricanes. So we see that the claim is that the x1 is greater than x2. Our null and alternative hypothesis, we see here, the null is always going to be that they're equal to each other, and the alternative is that one of them is greater than, less than, or not equal to. And since the claim is that the female named hurricanes is greater than, that's what's going to be an alternative, right? That's going to be, since the claim itself is including an inequality sign, we're going to have to put the claim in the alternative. We've already gone over that there are two specific ways to write the null and the alternative. One is to compare with equality or a greater than sign, or less than or equal to or not equal to, and the other is to actually represent these numbers with subtraction and using 0, since we're testing whether or not there's a difference or whether or not the difference is greater than 0. So now, with that being said, we're going to go to the data set. As I mentioned, I'm going to complete this problem two different ways. One is with the stat, t-stat, two-sample, and with summary, and then I'll complete it with the with data. Notice when we look at the with summary, we actually need to have the summary statistics for each group. So that means I need to have the sample mean deaths, sample standard deviation, and the sample size for the female named hurricanes, and also I need those statistics for the male named hurricanes. I can do this by going into stat, summary stats, and columns. And what I'm looking for here is I want to know, I'm using the all deaths column because I want to find those values for the number of deaths, and I want to group by the gender MF column. Now if we were to look in the gender MF column, we have a series here of 1s and 0s. This is called an indicator variable, where it's a binomial, pretty much a 1 or a 0. We have two options here. The 1 is indicating that it's a female name, and the 0 is indicating that it's a male-oriented name. So I'm going to group by, and since technically this is a number being used as a category, right? We're categorically putting these two or putting these hurricanes into groups, whether it's a 1 or a 0, whether it's a female or a male name. So that's what I'm grouping by. I want the number, I want the mean, and I want the standard deviation for each. I'll hit compute, and here we go. We have these values. Remember, 0 is for the male names, and 1 is for the female names. Now that I have these, I can go into stat, tstat, toSample, and with summary, and I can go ahead and plug these in. My first sample, remember, we had our X1. That was the female-oriented names. So if we look over here to the summary statistics, that was when the gender MF column was a 1. So we had 62 hurricanes that had a female name. The mean number of deaths for those hurricanes was 23.758. That should be good. And the standard deviation was 47.466. Sample 2, this was the other group for the male hurricanes. The sample mean we see is 14.233. Sample standard deviation is 21.162. And the sample size is 30. We are not going to pull their variances, and that's going to be consistent with what we talked about earlier in the module. We can't assume necessarily that the standard deviations are equal, and if you look, it doesn't look like they are coming from the same population here. We have the null is that they're equal, and the alternative, remember, was greater than, because our population mean, we thought for the female, the claim was that the female names had higher number of deaths. So now that I'm all set, I'm going to hit compute, and now I get my results. I'm given the parameters in the difference format, the sample difference, so that's like the mean difference between them. There's approximately a 9.5 number of deaths by average between them. The standard deviation is 7.16. There are 89.6 degrees of freedom. The t-stat is 1.33. And finally, the p-value is 0.0934. So approximately 0.09. If I go back, since our p-value was approximately 0.09 and alpha was approximately 0.05, what we have here is that the p-value is greater than. The p-value is greater than, so the p-value is greater than the alpha level. That means that we can fail to reject. There is not enough evidence to reject the null hypothesis. Just going by this particular method of looking at the mean number of deaths, we would state that there's not enough evidence to support the claim that the mean number of deaths is different for the two groups. Like I mentioned, this isn't what the authors and the researchers used to support their conclusions. They used other metrics and other statistical tests. We're taking a very simplified approach. The last thing I want to do is to show you how we can arrive at this conclusion without having to calculate summary statistics. With StatCrunch, we can actually split columns. So if I were to go into Data, Arrange, and Split, I can take that All Deaths column and I can split it by whether or not we have a female name or a male name. And what I can do is if I select Open in a new data tab or data table, what I get here is I get 0 all deaths and 1 all deaths. So the 0 all deaths, this column is telling me all of the male hurricanes and all of the death tolls for those hurricanes. And the 1 all deaths, this split the column here so that I have the female names. That's great because now I can go into Stat, tstats, toSample with data. And I don't have to calculate the mean, standard deviation, and sample size for each column. Instead, I can tell StatCrunch that the values that I want you to look at, the values for the female deaths are in the 1 all deaths. The male names are in the 0 all deaths. I'm not going to pull variances. And this was a greater than. And what we'll find when we do this is we're going to get the same same output, same p-value, same conclusion.